In this section we will review how to select data from multiple tables by using various table join types. First we will review how joins are made between tables by referencing primary, foreign and secondary keys. Next we will look at table and column aliases, which help you speed up your coding by creating shorthand references to tables and columns. Finally we will review 4 of the main SQL table join types found in databases that I would regularly use on a daily basis: the inner join, the left and right outer join, union, and Cartesian join type. As always, I would recommend that depending on the database you are using, to review the database documentation to identify which table joins are available to you. Let's now review a number of ways 2 tables can be joined together using SQL code. The first and probably the most common way is to use the primary and foreign key relationship. With regards to data normalization, we reviewed how by separating out grouped data components into separate dimensional tables, we could then reference the dimension table by means of a foreign key. For example, if we had a customer table, we might have a foreign key relationship to join to an address table by means of an address ID, which we can store in the customer table. When we want to know the value of the customer address, then we can join the customer table using the address ID to the address table to identify the address details of the customer. This type of relationship is known as a primary and foreign key relationship. Next we have what is known as a unique key. Such values are typically found in transaction tables, where a unique value is generated to represent the entire transaction. For example, if we had a table called fact customer transaction, we could generate a unique ID to identify each transaction row and call this the transaction ID. Such unique keys may be in the form of an integer that is incremented by 1 every time a transaction is created. Such a transaction ID can be used to identify how many transactions have gone through a system. Next we have the composite, compound, or concatenated keys. These keys take the form of having multiple values to uniquely identify a given row of data. For example, if we had our fact customer transaction table again, but we did not have a unique key in the form of a transaction ID, we could generate a composite key by combining a number of values together to uniquely identify each transaction, such as the customer ID, the transaction date and time, and the item number in the shopping basket. By combining these 3 or more values together, we can uniquely identify our row of data from other rows of data. Another example of a composite key might be within an aggregate table. For example, if we had a transaction summary table called Ag Transaction Country Month, which is a summary of transactions by country on a monthly basis, then we can make a composite or compound key by using the values of country ID and transaction, month and year. This also identifies for us the level of granularity in the table. However, don't always rely on the table name to identify the level of granularity. For example, we might have a table called Ag Country Transaction Month, which leads us to believe that the primary key is made up of country, month and year. But when we review the primary key, we also identify that there is product and subproduct fields within the table and key index. This would mean that each row is uniquely identified by country, month and year, and in addition, product ID and subproduct ID. When performing any aggregate calculations or selecting data from a table, we need to be aware of what is the granularity in the table, as this can cause double counting of data, in particular if we are trying to uniquely identify the number of customers for a given period. To give an example of double counting, let's say we have a value of 10,000 customers for the month of January 2018 in the United Kingdom who made transactions. Our table name of Ag Country Transaction Month leads us to believe that the granularity of the table is at country and month level. We then perform a count of customers and returns a count of 200,000 customers who made transactions in January 2018. Upon further investigation of the table, we identify that the table also contains product and subproduct details, of which there are 20 rows of data for the month of January in the United Kingdom. The value of 200,000 is made up of our 10,000 initial customers times the 20 rows of product details, giving us a value of 200,000. To correct this, we would perform a count distinct to provide us with the correct figure of 10,000 transactions or customers, or we could use an alternative table that does not contain product and subproduct details. Next, we have secondary keys. While secondary keys are typically non-unique, they can be used to help identify a row of information. For example, values such as first name, last name, salary, department, country can help us to identify a given row. And for such keys, we can gather what is known as statistics on these values to help us with our queries within the data warehouse. For example, with country, we can collect statistics on this field, which will identify the unique number of countries within our data. For example, if our company had business within 5 countries, by collecting such statistics to identify how many countries we're doing business in, a database administrator can then look to partition out the data by country, which will allow for much faster query returns of data if we are specifically asking for individual countries and the data is then stored in a specific location in our database. You will often see secondary keys utilized within aggregate tables are not uniquely identified by the secondary key. Having such statistics and data distribution will help us greatly with enhancing the performance of our database. Finally, we have superkeys, which are similar to compound composite keys, but are made up of a number of different permutations of key index values. For example, we might have transaction ID as a unique primary key, followed by a superkey of transaction ID plus customer name, followed by another superkey of transaction ID plus the address ID, and the final superkey of first name and last name. Each of these superkeys will help us with the distribution of data within a table, which again helps with the performance of a database and the time it takes to return data back from a query. Such superkeys may be set up to allow for joins to additional tables that support the superkeys and don't necessarily have the likes of a transaction ID to join on. Next, we will look at table and column aliases.